Okay, hello everyone. I welcomes to all once again in our lecture series on some special integrals, and we are discussing gamma function. In our last three classes we have been discussed gamma function and its different forms of gamma function. This is second, third and fourth form of the gamma function we have been discussed. Then we have been discussed some properties of gamma function, that is your gamma n plus 1 equal to n gamma n, gamma 1 equal to 1, and gamma 0 infinite, and gamma minus n equal to infinite. Here you have to remember this is the integer, n is for your integer. I am going to recall you that here in the definition it has been written that gamma n equal to 0 to infinity x to the n minus 1 e to the minus x dx for n greater than 0, and here n is your integer. Greater than 0 means here positive integer, n is your positive integer. I am going to write once again. So as n greater than 0, so obviously it will be positive, but positive integer. Okay, n is your positive integer. And here you can see in the properties what we discussed, gamma minus n we found infinite, and here n is your positive integer. So obviously this will be your negative integer. For n negative integer we are going to get the minus infinite. But if n is fraction, either positive or negative fraction, the value of gamma function not equal to infinite, it has some value that we are going to find out, or we are going to discuss in this particular video by using this one fifth property, that is your gamma 1 by 2 or gamma half equal to root pi. So in this video or lecture particularly we are going to discuss evaluation of gamma function having positive and negative fractions. Okay, so first of all we are going to discuss the fractions like this type of fractions. 1 by 2 already we have been evaluated, that value is root pi. 3 by 2, 5 by 2, plus or minus 3 by 2, 5 by 2, like this. That means numerators are your odd values. Then we are going to draw a graph by considering these positive and negative values of gamma function. From that we can predict the other fractional values of gamma function. Okay, so first of all we are going to evaluate all the positive fractional values of gamma function having numerators are odd values. Okay, and the denominator will be always 2. Then we can found easily the values, or we can easily evaluate by using this one, gamma half equal to root pi. Okay, one by one we are going to discuss. So let us start. First we are going to find out the value of gamma 3 by 2. Already gamma half we evaluated. First we are going to find out gamma 3 by 2. First I am going to put the heading finding up a positive fraction, like this. For positive fractions, okay, for positive fractions, first I am going to consider if n is your 3 by 2, that means gamma 3 by 2 value will be how much. Okay, already gamma half value already we found root pi. So gamma 3 by 2 value, how we are going to find out? Here you can see gamma 3 by 2 can be written as, that implies gamma 3 by 2 can be written as gamma 1 by 2 plus 1. This gamma 1 by 2 plus 1 is nothing but 1 by 2 or half, gamma half, by using first property. By using first property, that was gamma n plus 1 equal to n gamma n. Okay, so here we have gamma 1 by 2 plus 1, so it can be written as half gamma half. So that implies the value of gamma 3 by 2 will be equal to half root pi. Okay, okay, next we are going to find out gamma 5 by 2. Second bit we have to evaluate what will be the value of gamma 5 by 2. Same procedure we are going to consider like this. Gamma 5 by 2 can be written as gamma 3 by 2 plus 1. This can be written as 3 by 2 gamma 3 by 2. Okay. So here I can directly substitute this value gamma 3 by 2 value. Already I have been evaluated 1 by 2 root pi, or suppose in your exam it has been asked gamma 5 by 2, you just derive like this 3 by 2 gamma 3 by 2. Then next step 3 by 2 can be written as gamma half plus 1. This will be equal to, that implies gamma 5 by 2 will be equal to this one 3 by 2 into 1 by 2 gamma 1 by 2, which will be equal to 3 by 2 into 1 by 2 into root pi. Okay, or this will be equal to 3 by 4 root pi. Okay, similarly 7 by 2, 9 by 2, any value you can find out, or here you can write in general, in general uh, in general in general gamma n by 2 will be equal to, and here you have to remember that this n is your odd value, this n is always odd. Okay, so for n by 2, gamma n by 2 value, we can write in general as n minus 2 by 2 into n minus 4 by 2 up to लास्ट टर्म क्या आएगा 1 by 2 root pi. Okay, you can see if I consider gamma 3 by 2, here you can see 3 by 2, first term was your 3 minus 2, 3 minus 2 is your 1 by 2, already 1 by 2 gamma half, this term came. If I am going to consider 5 by 2, what we found, here you can see 3 by 2 is the first term, then second term 1 by 2 root pi. So always 1 by 2 root pi is the last term. So the previous term for 5 by 2, if I am going to consider 5 minus 2 is your 3 by 2, then into 1 by 2 root pi, we found 3 by 2 root pi. Likewise, this is the general expression to find the gamma n by 2 when n is your odd. Okay, now we are going to go for the negative fraction. Just put a heading for negative fraction, and always we have to remember here what we are going to consider, the n is always odd. Okay, for negative fraction, first we are going to consider gamma minus 1 by 2, gamma half. So how we are going to find out the gamma half, here you can see, here to evaluate gamma minus half, consider gamma half. Okay, consider gamma half, and this gamma half can be written as gamma minus 1 by 2 plus 1. Okay, that implies here you can see gamma minus 1 by 2 plus 1 can be written as minus 1 by 2 gamma minus 1 by 2 by using first property, Okay, first property of a gamma function will be this one. So that implies here you can see this gamma minus 1 by 2 will be how much, gamma minus half will be equal to, this term will be moved this side, and this value is nothing but gamma half, so it will be minus 2 by 1, this value is nothing but only half, or 1 by 2, gamma 1 by 2. So that implies we found gamma minus 1 by 2 will be equal to minus 2 by 1, gamma half value is your root pi. Okay, here we found gamma minus half value is your this one. Okay, now this is your first bit. Second bit, now we are going to consider gamma minus 3 by 2. Gamma minus 3 by 2 value will be how much? So to find the gamma 3 by 2, you just consider this one. Consider gamma minus 3 by 2, gamma minus 3 by 2 plus 1. Okay, gamma minus 3 by 2 plus 1. So this term gamma minus 3 by 2 plus 1 can be written as what? Can be written as minus 3 by 2 into gamma minus 3 by 2. So that implies gamma minus 3 by 2 will be gamma minus 3 by 2 will be equal to, if this will be moved this side, it will be minus 2 by 3 into gamma, this one, minus 3 by 2 plus 1. That means gamma minus 1 by 2, right? So that implies gamma minus 3 by 2 will be written as 2 by 3 minus 2 by 3 into gamma minus 1 by 2. Already we have been evaluated this one, minus 2 by 1 into root pi. I can put directly, no need to do once again. I can put the value of this one, that is your minus 2 by 1 root pi. Okay, so or we can write this one, value is your 4 by 3 root pi. This is the value of gamma minus 3 by 2. Now we are going to consider gamma minus 5 by 2. Third eye, we have to find out gamma minus 5 by 2 will be how much. Likewise, same procedure we are going to consider. First we are going to consider gamma minus 5 by 2 plus 1, which will be equal to minus 5 by 2 gamma minus 5 by 2 by using first property. Here I not written, maybe you can write by using first property, here by using first property of gamma function, that is your gamma n plus 1 equal to n gamma n. So here from this expression we can write that implies gamma minus 5 by 2 will be equal to minus 5 by 2 will be equal to, here this term will be moved this side, this will be minus 2 by 5 into gamma minus 3 by 2, because minus 5 by 2 plus 1 is nothing but your minus 3 by 2. So that implies already minus 3 by 2 value we have been evaluated, that I am going to substitute directly. Gamma minus 5 by 2 will be equal to minus 2 by 5 into gamma minus 3 by 2 value is your this one. I am going to substitute over here. That will be minus 2 by 3 into minus 2 by 1 into root pi, or this value will be minus 8 by 15 root pi. Likewise, any gamma n by 2 where n is your odd can be evaluated. So in general, what we can write? In general, gamma minus n by 2 where n is odd will be how much? Okay, so here you can see when gamma half we are going to consider, this is your minus 2 by 1 root over of pi. Then for 3 by 2 we found minus 2 by 3. Here you can see 3 by 2 we are trying to evaluate the value, it is just reversely written, minus 2 by 3, then minus 2, numerator also minus 2 by denominator is 1. So here 2 minus 3, sorry, here 3 minus 2 will be 1. Minus 5 by 2, here you can see minus 5 by 2 means how much? First term is your minus 2 by 5 into minus 2 by 3 minus 2 by 1 root pi. So here you can see minus 2 by 1 is your last term. You just consider last term, right? And for each time the denominator decreased 2, but the numerator always minus 2, right? Gamma minus n by 2, in general what we can write? Gamma minus n by 2 will be equal to, here you can see always last term is your minus 2 by 1 root pi. So up to this much we have to move, but first term always the reverse of this one, so I have to write blindly minus 2 by n. Okay, then next term will be minus 2 by, here you can see second term is your the denominator decreased by 2, 5 minus 2 is your 3. Here you can see, here in this case also first term was denominator 3, second term 1, so 3 minus 2 1. Likewise here we can write second term the denominator will be n minus 2. Okay, n minus 2. Then third term will be minus 2 by n minus, here you can see n minus what we can write here, first term 5, second term 3, that means n minus 2. Again here we are going to consider minus 2, that means from the first term it is reduced to 4. 5 minus 4 is your 1, 3 minus 2 is 1. So here n minus 4. Okay, then fourth term will be 2 minus 2 by n minus 6. That means each time the denominator will be reduced by 2 up to the last term will be minus 2 by 1 into root pi. So when this term will become, that is the last term. Okay, so in general gamma minus n by 2 will be this one. So by using this one directly, if I'm going to consider, suppose in your exam it is asked that find gamma minus 11 by 2, okay, will be how much. So if you are going to do by this method, it will be so long, because first you have to find out gamma minus 5 by 2. If you remembered, okay, the value of gamma minus 5 by 2 is your minus 8 by 15. Gamma minus 7 by 2 also you have to remember. The value of the gamma minus 7 by 2 you have to remember. But if you remember this general expression, so no need to remember all the values of previous gamma values. No need to remember gamma 7 minus 7 by 2 minus 5 by 2, etc. So here gamma 11 by minus 11 by 2 will be how much. Here you can see this is your answer. Directly you have to write gamma minus 11 by 2 will be equal to, first term will be minus 2 by 11, I written, then minus 2 by this 11 will be reduced by 2 each time. So second term will be 9, then third term will be 7, minus 2 by 7, minus 2 by 5, then minus 2 by 3, then minus 2 by 1, this last term came, then root pi will be automatically come, and you have to write after this term root pi. Okay, so here it will be 2 into 2 into 2, 1 2 3 4 5 6, so 64, 2 to the power 1 2 3 4 5 6, so it will be 64. Here minus how many times minus? 1 2 3 4 5 6 6, so it will be plus, divided by, you have to multiply this much, 11 into 9 99, into 7 into 5 35, into 3 root pi. This value will be the answer. You just multiply the denominator. Okay, so here we have been evaluated positive fraction and negative fraction, where the numerator is your odd value and denominator always 2. So gamma 3 by 2 is this much, gamma 5 by 2 we found, gamma n by 2, n for any odd value we can also evaluate by this general expression. Likewise negative fractions we have been evaluated. Now you are going to ask the question that yes, we have been evaluated gamma minus 1 by 2, gamma minus 3 by 2, gamma 1 by 2, gamma 3 by 2. That means if I am going to draw a graph, this is your 1 2 3 4 5, this is your 0, and minus 1 minus 2 minus 3 minus 4, this is your 1 2 3 minus 1 minus 2 minus 3. So here we have been evaluated gamma half. Gamma half means here at this point some value we have been found. Okay, gamma 3 by 2, that means at 1.5 also we have been found. Gamma 1 value already we have been evaluated. Gamma 2 value is nothing but 1 factorial. Gamma 3 value is nothing but 2 factorial, that we know. And here most important, as we have been already discussed, negative integer gamma value, that means gamma minus n, n is your integer, any integer will be infinite. Already we have been proved that one. So gamma minus 1 by 2 minus 1 minus 2 minus 3, at these points gamma function value is infinite. I'm going to draw this figure perfectly, you just wait. Here at 1 by 2 this value is infinite, and 0 also infinite. But at minus 1 by 2, how much we found? Minus 1 by 2, minus 1 by 2 we found minus 2 root pi. So if I'm going to calculate roughly, root pi is around value 1.77. root pi value around 1.7, पकड़ लो 1.7, let 1.7, and here -2. -2 means if I am going to multiply -2, then it will be 2 into 7, 14, 3.4, around -3.4. The value will be -3.4. So here this value will be roughly -3.4. So -3.4 will be where? Here. If we are going to consider this is -1, -2, -3, then at -1/2 this value will be here. Okay, then if I am going to approach 0, then this will be infinite, and if I will approach -1, this will be infinite. Okay, likewise at this point we have some value, positive value, and if I will approach -1, it will be infinite, it will be infinite. Likewise in between -3 to -2 the value will be some negative value, and it like this. So from this graph someone can predict the other fractional values of gamma function. That means here if I'm going to consider this point is belongs to gamma -1/4. So perfectly if I'm going to draw the graph by considering gamma -12, -3/2, 1/2, 3/2, then after drawing the graph, this value gamma -4, 1/4, the value will be somewhere here, can be predictable. Okay, so here I'm going to draw this graph perfectly for you. Here you can see. So here you can see these are the value I have been written over here. Gamma half equal to root pi, the value approximately 1.77, and gamma minus half we found -2 root pi here, -2 root pi, that is approximately -3.4. Gamma 3/2 we found half root pi, that is your 1.77/2, approximately 0.8. Gamma -3/2 we can found 2.2 plus. Gamma 5/2 we can found 3/4 root pi, the value will be 1.28 approximately. Gamma -5/2 will be we found -8/15 root pi, approximately it will be 0.9, or we can say 1. And gamma 0 is your infinite, and gamma any negative integer also infinite. So by substituting these values we are going to draw the graph. Here you can see gamma half. If I'm going to consider gamma half, okay, gamma half 1.77. So here gamma half, okay, this side is your value of your n, and this side along y axis is your gamma n, right? So this is your half. So gamma half value 1.7. So this will be 1.5, 1.7 matlab approximately this value, this much, right? Okay, okay. Then gamma 1 we know that 1, gamma 1 1, gamma 2 also 1, gamma 1 here, gamma 1 1 we know, gamma 2 will be also 1, because gamma 1 plus 1 we can write, and this will be 1, gamma 1 value also 1. But gamma 3 is your 2 factorial, gamma 4 3 factorial, it will be increased. So gamma 3 is your 2 factorial or 2, this value. Okay, okay. Gamma 4 is your 3 factorial, means 6. 6 means somewhere this value is 5, somewhere you can consider here like this. So if I'm going to draw this graph, yes, gamma 0 value is your infinite. If I will move towards this side, so it will be infinite. So by considering these points, if I will draw the graph will be like this, approximately like this. I'm going to draw in the red, it will better. The graph approximately like this. Gamma 1 1, then it will be increased sharply. Okay, so now if we want to find out, somebody want to find out gamma, here this value is half. Okay, this value is gamma 1/4, gamma 1/4 approximately we can found the value will be this much. Okay, gamma 1/4 I'm telling, gamma 1/4 this much. And here this value, here in between 1 to 2 the value will be 1. Okay, 1 to 2, sorry, gamma 1.5, 1.5 value here, gamma 3/2 is nothing but gamma 1.5, value is 1.8. That means here I done a small mistake, that gamma 1 is 1, gamma 2 is your 1, but gamma 1.5 here the value will be 0.8 like this here. So it will be somewhat like this. Okay, because this value is your 0.8, right? So likewise 2.5, or this is your 2.5. 2.5 means 5 by 2, 5 by 2, gamma 5 by 2. So in between 5 by 2 and 2, any value if we want to find out, then from this graph we can easily evaluate. Right, now we are going to move towards the left side of this graph, that means negative. Here gamma 0 is infinite, gamma 1 minus 1 also infinite, minus 2, all the negative integers will be give the infinite value. Now gamma minus 1 by 2, this value, gamma minus 1 by 2 value is your minus 3 by 2. So minus 1 by 2 means here somewhere, gamma minus 1 by 2 value is minus 3.4, approximately 3.5 you can say here. Okay, here this value, right? Then gamma 1 is your infinite. So the graph will be like this. The graph will be like this. Gamma, if I will move towards minus 1, it will be infinite. If I will move towards 0, also it will be infinite. Okay, okay, okay. Now we are going to consider gamma 3 by 2. Gamma 3 by 2 means here, that means minus 1 by minus 1.5. 3 by 2 means 1.5. Value is 2.2. 2.2 positive. 2.2 matlab somewhere here 2.2. This value is 2, so 2.2 somewhere here, right? Again minus 2, if I will approach towards minus 2, it will be infinite. Minus 1 also infinite. The graph will be like this. Okay, okay, okay. So in between, this is your minus 1.5, minus 1.5 value. In between minus 1.5 to minus 1, if you want to find out the value will be some will be this much value, right? From this graph we can evaluate. Okay, then minus 2 to minus 3, that is your minus 5 by 2. Minus 5 by 2 means minus 2.5. Minus 2.5 means here. So at gamma minus 5 by 2, the value is your minus 1. So here minus 8 point minus 8 by 15, or the value is minus 0.9, or this is minus approximately minus 1. So minus 1 means somewhere here. Minus 1 means somewhere here. Here, exactly here. Minus 1 means somewhere 0.9, minus 1 somewhere here. Okay. Then if I'm going to move towards minus 3, it will be infinite. Minus 1 also infinite. The graph will be like this. Okay. Okay. So from likewise we can evaluate the value at this point like that, and we can draw the graph. After drawing the graph, any fractional value, that may be negative side and positive side, we can evaluate. Okay, gamma, any fractional value can be evaluated, but we have to remember any negative integer, at any negative integer, the gamma value is your infinite. Okay, so this is all about your evaluation of gamma function having positive and negative fractions. Okay, hopefully this video will be useful for your exam point of view. No need to bother about your note. I will upload this writing as PDF. You just download and watch this video, okay, for your exam. In our next class, we are going to solve some numerical based upon a gamma function. Okay, some important numericals we are going to solve. So thank you so much for watching this video. Thank you.